Nature reports the discovery of a crucial missing link in the ancestry of the cetaceans, porpoises, dolphins and whales.
Ever since the time of Darwin, scientists have known that whales were descended from land mammals. But until very recently, about 15 years ago, the ancestors of whales were not known, and creationists had a field day because there were no intermediates. In the last 15 years then, a number of remarkable transitional forms have been found that document the transition and the morphology of these early whales very nicely. One such form is Cuchicides. Cuchicides is about 45 million years old, and as you see from the skeleton, it had a long tail and relatively short legs. It was an animal well adapted to swim in water. Before Cuchicides lived Ambulocetus. Ambulocetus is about 49 million years old, and it lived in nearshore marine seas in Pakistan. Its habit were probably sort of like a crocodile. And then, discovered most recently in 2001, is the skeleton of Pachycetus, the first known whale, which didn't look anything like a whale. It really looked like a wolf or so if you would see it in a zoo. However, we know that this was already an aquatic animal because of the structure of its bones. They are very dense. This was probably an animal that was wading in shallow water. It was not a swimmer. What was missing at this point was the link to the land relatives of whales. And with our new Nature paper, we think we have found it. And that link is Indohyus, which I have been studying with Mark Clemens, Sunil Bajpai, B.N. Tiwari, and Lisa Cooper.
So just where in the fossil record does this newly discovered species fit?
The fossils are found in Kashmir, close to the Pakistani border, which is a difficult state to work. So the Indian scientists that we worked with and that collected the newer fossils, and they went back to this site and collected some more fossils. They were collected as blocks of rocks.
The blocks have been marked with the locations of fossils, but it can take years of careful work to extract and identify the most significant bones. The secrets of Indohyus only just now being revealed, more than 15 years after the fossils were collected.
I think the most exciting moment came when my technician was preparing the skull, and he by accident broke the ear off, and he was ready to glue it back, and he showed it to me. And I realized that on the broken surface of this ear, you could see that the inside of the bone was very thick, just like a whale, and not like any other land mammal.
My contribution to this study was to actually look at the bone structure, specifically of the bones of the limbs. And when we look at the bones of Indohyus, in general, they look just like a regular terrestrial mammal, a mammal that was walking on land. But when we look at the thicknesses of the bones, that's when the whole story changes. The bones of Indohyus were actually extremely thick. This is the kind of thing that we see in animals like hippopotamus that live almost entirely in the water. Although they can walk on land, their skeleton has changed that allows them to basically walk on the bottom of a river bottom. So what we do with Indohyus is we actually section the bones and then mount them on slides, and we grind them down until we can see light through them. And what that'll show us is something like this. Here you can see in a fossil of an animal that was actually living on land, that was basically a small deer, you can see that the bone layer is very thin here. But when we look at Indohyus, you can see that the bone is actually very thick compared to the inner medullary cavity or the bone marrow. And that indicates that Indohyus was in fact aquatic or wading in water. We can also take these slides and put them through different polarizing filters, and that's what will give us a really beautiful image.
To all this evidence, Mark Clements of the University of Wyoming has added an analysis of both oxygen and carbon isotopes in the teeth of Indohyus, providing further evidence of the amphibious life of this animal. So the new species Indohyus helps bridge a 10 million year gap in the fossil record. And Hans Thiersen has further studies to do. He's exploring the balance mechanisms in the ears of each species.
Many of these early whales have very small organs of balance, which is sort of counterintuitive because you would imagine that a whale who lives in a very three-dimensional environment has very good balancing organs, but they don't. And we've looked at this in a number of early whales, and we know that that changes very early in whale evolution. Indo-Hyas is an animal that we haven't studied with regard to this, and that's one thing that we definitely want to do too.
As a graduate student, it's a tremendous opportunity to be able to work on a project of this caliber, because not only am I learning the techniques of being a good scientist from Hans, but also the discovery of this fossil is tremendous. And one of my great passions in life is to study the evolution of cetaceans and whales, dolphins, and porpoises. And it's been just a thrilling find to be able to understand more of cetacean evolution. And the fact that we found that Indo-Hyas was aquatic is a profound and amazing realization that casts the evolution of cetaceans in a whole new light. And so to actually be part of this kind of finding is really gratifying.